Greetings to everyone. Greetings to everyone. Today's topic is data visualization. So, what is data visualization, and what is the use of data visualization, and what are the tools that are supplied by our language? So, in R, we can create visually appealing data visualizations by writing few lines of code. For this purpose, we use various functionalities of R. Data visualization is an efficient technique for gaining insights about the data through a visual medium. With the help of visualization techniques, a human can easily get information about hidden patterns in data that might be neglected in normal cases. So, before going into the practical session, uh, we have to learn some of the definitions. So, uh, what is categorical variable? A categorical variable contain a finite number of categories or distinct groups. Categorical data might not have a logical order. For example, categorical predictors include gender, material type, and payment method. See that gender gender contains two different groups, right? Different groups, male or female. So category, right? That is a category. And material type, based on the material, maybe you can contain 5 types, 10 types, but the 10 types must be different, right? So so if you have a data set, in that data set, if any column contains such kind of categorical variable like male, female, right? Product 1, product 2, product 3, again product 1 repeating. So such kind of field comes under categorical variable. Then next definition is, what is quantitative variable? So quantitative variables are two types. One is descriptive and another one is continuous. Discrete variables, see that discrete variables are numeric variables that have a countable number of values between any 2 points. Here I will change this as points, between any 2 points. A discrete variable is always numeric. For example, number of customer complaints. So number of customer complaints between 2 points. That means from day 1 to day 5. How many number of complaints from the customers? We can count that, right? So that, see that they are countable. So in data set, the values which are in numeric format and they are in countable, so they comes under discrete variables. And coming to the continuous variable, these are also numeric variables, but the difference between continuous and discrete is uh, these have infinite number of values between any 2 points. Note that they are having infinite number of values between any 2 points. A continuous variable can be numeric or date time. See that date is a continuous variable, right? There is no end point for the date. Every year new calendar will come, so new dates will come. And time is also continuous variable, right? For every second the time keep on moving, we can keep. And there is no end point for the time also. And one more definition is outlier. Outliers are the values that are beyond their average values. See that beyond their average values means I am expecting a value ranging from 1 to 10, but the resulted output showing that the value is 100, but my range is what, 1 to 10. So the result value is 100, so that is beyond the expectation, right? So they will not fit into the actual boundaries. The values that are not fit into the actual values. You can see that if someone is having a favor, 110 favor is valid, 100 favor is valid. Have you seen the favor of a person is 1,000. So such kind of values are outliers. So what are the tools do I have for the data visualization? Paid tools are available, open source tools are available, but paid tools give better results and well compared to open source, but they are costly, right? So paid tools, there are two paid tools, Tableau and Quick Click View. So paid tools, maybe they are initially costly to purchase, but the solutions provide them are definitely worth the money you spent. And Tableau is available free for 15 days if you have a student login. And the Quick Click View also provides a business intelligence application for entire your company, only one application for entire your company, but you need to pay for them. And some of them are open source, they are available with along with the code. So those are in Python. There are two packages. In R also there are two packages. In Python you can use matplotlib and cbon. And in R language you can use ggplot2 and ggvas for visualization. We will see ggplot2 in our lecture session. Okay, see that. What is data visualization, right? So basically the data is available in data frames or in data sets. The data sets will be loaded into our environment in the form of data frames using the data that human cannot predict by looking at the data, but a human can predict the insights about the data using graphical representation. So graphical representation in the R language is nothing but a visualization of data. We can provide graphical representation for the data using these 7 kind of charts. So these are the 7 types of charts. Using these 7 types of charts, we will give a graphical representation for our data sets. So how many types of representations are available? Nothing but how many types of presentations are available. See that there are 4 types of presentations are available. You can compare two variables. That means we have seen 3 types of variables, right? Continuous variable, discrete variable, categorical variable. So you can compare any two variables. You can you can estimate the composition of two variables. You can plot a variable along x-axis. That means a distribution is possible. You can find the relation between two variables. So these are the 4 presentation types we can do with 7 types of charts. Now the question in your mind, how to select right chart, because there are 4 types of presentations and 7 kinds of charts. Using 7 kinds of charts, you are going to present 4 types of presentations. How to select a right chart? So for that you need to learn where we need to use a proper chart. So for that scatter plot is used between two continuous variables, and histogram is used to plot continuous variable, and it breaks the data into bins. Bin means a rectangular box in the plot area. We will see that in the practical session. So and a bar chart are recommended when you want to plot a categorical variable or a combination of category and continuous variable, right? Bar chart is used when you want to plot a categorical variable or a combination of continuous and category variable and on the x and y axis. Then box plots. Box plots are used to plot a combination of categorical and continuous variables. This plot is useful for visualizing the spread of the data and detect outliers. So outliers, I think you know the definition. Remember that definition. So using box plots, we can find the outliers in the data. Area chart. See, area chart is used to show the continuity across a variable or data set. So it maintains the continuity. Continuity nothing but point to point. It doesn't lose any link. So that means it is much same as line chart. Heat map. Heat map uses heat means whenever there is an intensity or a density, then it means it is nothing but a heat, and then a particular intensity or density of heat is represented in the form of colors. So it displays relationship between two or three or many variables in two-dimensional image using colors, using the intensity colors. The third dimension will be visible using intensity of colors. Correlagram. So correlagram is used to test the level of correlation among the variables available in the data set. Right? These are the 7 kinds of charts. We will see the summary, right? Summary. This is the summary. Scatter plot. Two continuous variables. It gives relationship between two continuous variables. Histogram. Plot continuous variables. Bar chart. Plot categorical or combination of continuous. Box plot. Plot combination of categories and a continuous variable, but using box plots we can find what? Outliers also. Area chart used to show continuity across a variable or data set. Heat map. It will use it to display the relationship between the two or three or many variables, and using color representation. Correlagram used to test. It is used to test the level of correlation among the variable available in the data set. Uh, in our lecture video, we will see standard graphics in our language. The standard graphics is supported by the package graphics. So graphics is a package that supports standard graphic techniques for visualization. So we will see some of the uh, charts using this standard graphics in every R environment. By default, this graphics package was installed and that was loaded. No issue to reinstall it again. So we will see the first chart. We will go with the pie chart. So we will see the syntax of pie chart. Pie chart is created with a function called pie, and it takes these many parameters. So x is a vector, so that is a numeric vector, and labels are used to give description for the slices. Radius describes the radius of the pie chart. Main, and main is for in every chart, not only in pie chart. If you come across any 7 types of charts, if you have a parameter called main or COL. Main is for the title of a chart, and COL is for the color of a chart. Okay, and last parameter is clockwise. There are many parameters available, but I am taking only important parameters here. Clockwise is a logical value that indicates the clockwise or anti-clockwise direction which the slices are run. If you set the clockwise, it is logical value, right? It takes only two values, either true or false. So we will see that in our practical session. So for our practical session, what I am taking is I will open my R Studio here. In R Studio, I'm taking, I think it is visible to you. I'm creating a vector. So in vector, I'm taking values numeric. So it is a numeric, right? So I'm taking four numeric values. Vector is created, and I'm taking another vector also for labels. And these I'm taking character vector. My character vector. I'm taking country names. So we will take the function called pi, and the first parameter I'm passing vector, and as the second parameter I'm passing my labels, and you can give color attribute also. Color is equal to whatever color that you like. I'm taking as a green. And then what, if you want, you can take you can give name for the chart also. Name is given with the parameter what, main countries. And I'm taking color, only one color here, right? So if instead of one color, if you want to give uh, different colors for different part, you can see this here, you can see that. So here you can see this is normal pie chart. If you wanted to apply different color for different slices, so this is the name for the this slide, this is name for this slice, right? So you can use, I want how many colors there, how many sizes are there. I need to find how many sizes are there. If number of slices are is equal to number of colors that I want. So I'm using pi comma col is equal to, I'm using rainbow function, rainbow length of x. I'm taking x is a vector, right? I'm finding the length of x, then using rainbow color, from the rainbow color set I am taking 4. This function returns 4, right? Number of values in the x, this value returns 4, so rainbow function gives 4 different colors. You can see the difference. This is the using rainbow color set, and this is the previous chart. This is the previous chart, you can find. This is the present chart, and you can mention legend also. Legend means I want my legend to be top right here, so use the first parameter top right, comma. If you want to give labels also, labels, where I have labels in x, right? So I have labels in x, so definitely you can use that, and x, or otherwise instead of labels you can directly give the names where it is available. So y, in y variable I have names, right? So definitely I will y. And cx stands for character expansion. Character expansion, and if you want your text to be appeared in uh, a size, you can mention the size of a text here, 0.8. I'm mentioning the size of a text along with labels. And I'm taking again fill is equal to rainbow length of x. You can execute this, see that this is the graph, this is the pie chart, this is the legend. So character cx stands for character expansion. I am given 0.8, right? If you want to increase the size of the text, you can mention much valid value. So you can create another pie chart also, that is a three-dimensional pie chart also. For that you need to install plottricks package. But if you have already installed in your R environment, no need to reinstall it again. Directly you can load this using library function. So plottricks was loaded. Now I need to use pi 3D function. So py3d function takes first argument as usual x, and labels is equal to y, and then explode is equal to 0.2, and name for the pie chart, countries, just enter. You can see this is the normal pie chart, and this one is the three-dimensional pie chart. So this is all about what? This is all about the pie chart. Now we will see another chart, that is bar chart. So we will see the syntax of bar chart. This is the bar chart. We can create a bar chart using bar plot function. As a first argument it takes vector or matrix, and remaining L, X label, Y label, main is common, names.org is used for a vector of names that appear under each bar. We will see that in practical, and color is for mentioning color. X label means X axis name, Y label means Y axis name. We will see that in practical. So what is the function? Bar plot, right? So bar plot, first argument is what? Vector or matrix. I am taking vector because vector is already available, and next is I am taking names dot arg. Arg stands for arguments, name dot argument. So here I have names in y vector, so directly I am passing that y, and x lab. For x-axis I wanted to give a name month, and for y lab, lab stands for y label. For y label I want to give a name revenue, and if we want to mention color for bar plots, color is equal to green or red. Okay, enter. See that these are the bar plots, and for each bar you can see the name. For each bar there are names, so these are appeared because I am using names dot arg is equal to y. Y contains all these names, right? So, and x lab, x label name month, y label name revenue, right? Then, so if you want to give border, for border a color, so use border is equal to green, enter. See that you get the border into green, right? So then next part we will go to box plot. So we will see the syntax for the box plot. So syntax for the box plot, and it was created using a function called box plot, and as a first argument it takes what? A vector or a formula. How to create a formula, we will see that. And see the second argument in the box plot, that is very important. The second argument in the box plot takes data frame. So data frame or data set, we need a data set. From the data set you need to select one vector or one formula. You need to generate one formula. So then notch means a line. So this, in these box plots, their values, the line indicates average value, maximum value, minimum value, first quartile, third quartile. So the line is drawn based on these representations. Then var width, it is also a logical value. Logical means true or false. Set as true to draw width of the box same as the sample size. If you want the width of the size equals to the sample size, then you can use var width is equal to true. So, and then names, it is the group of labels that will be printed under each box plot. So right, and it is used to give name. Main is used to give title for the graph. We will see that in practical. What is the function name? Box plot, right? So box, before writing a box plot, I want data set, right? I am taking the support of predefined data sets available in the R environment. One of the predefined data sets is empty cars. So empty cars is a data sets. I'm taking the support of that. In the empty cars, you can see the empty cars data, view of empty cars. Press enter. So see, these are the field names. These are the field names. So these are the data values. So right, mpg, cyl, mpg, miles per gallon, cylinder, display, horsepower, right? These are the column names available in the empty cars data set. I'm taking the support of empty cars data set. So no need to recreate it again. I have already data set, so I'm taking that support and I'm using box plot. So first argument, either it is a vector or formula, right? I am taking formula mpg tilde cyl. So what it stands for? mpg is a function of cyl. That is the representation we need to call the mpg tilde cyl is a function of mpg, right? And another parameter that I wanted to give is data. Data is equal to what? Here I have data set of empty cars. So next parameter is x label. You can give x label as mpg, and another thing is y label, ylab is equal to cylinder. I am taking cyl. And if you want to give a name for the chart, main, and here you can take box plot example, and you can pass colors for each block. Here you can see, not without colors, you can see the box plot. This is the box plot. So if you wanted to mention or give colors, comma, use COL parameter. For COL you can supply combination function, because I need to pass three different colors for three boxes, but I have only one parameter. In such cases you can take the support of vector. In the vector you can pass three colors: green, red, yellow. Enter. You can see colors of the box plot are different for each box. And you can use another notch, another parameter. Notch is equal to what? True. See that this is the notch, okay, right? We will go to another chart, histogram. So we will see the syntax of histogram here. Histogram is created using hist function, and as a first parameter it takes numeric vector, and main is common, x label is common, y label is common, x limit and y limit. See that x limit, these are the histogram, right? Histogram is nothing, is similar to box plots. So you can mention the range of x-axis, and you can mention range of y-axis using x lim and y lim respectively. And you can use color border also, and breaks are used to mention the width of each bar. It is used to breaks are used to mention width of each bar. We will see that in practical. So I will open my R studio again. If there are any warning messages, no need to look at that. You can go with your new chart. What is that new chart? Histogram. So I'm taking histogram. As a first parameter I'm passing what? X, and as a second parameter I'm taking x label. X label I'm taking weight, and as a y label I'm taking frequency, and I'm taking color for each bar as green, and you can give border also if you want. Border is equal to red. So this is my histogram. Press enter. Look at the graph. So this is the graph. Okay, what type of graph is? Histogram of X. And I haven't used a parameter called main. So by default it is taking histogram of X. X is a vector, right? Okay. And another graph that we need to see is a line graph. So we will see the syntax of line graph. Yes, this is the syntax of line graph. You can see that line graph is created using plot function. So it takes a first argument as vector, that vector must be numeric, and the second parameter is important to see that the second parameter has three values. So if you pass a value L on the plot area, it will display a line graph. uh, if you pass p as a value for type argument on the plot area, it will display points. If you want to combine points and lines, then you can supply o as a value for type argument, and remaining all are common. X lab is common, y lab, main, color is common, while along with other charts we will see. So see that what is the function? Plot is the function, right? Plot, I'm taking vector x, and type is equal to, first I'm taking L stands for line. It will display line for the values available in the X, right? And I'm taking color is equal to red, and I'm taking X lab. If you want you can take, otherwise no issue. X label is equal to month, Y label is equal to temperature. See that this is the line graph. So, and if you want to change that line into points, so instead of L you can supply P here. Enter. See that points, see the points here, right? And if you want both has to appear in your plotting area, you can supply the value O for type argument. See that those are appeared, right? So these are the some of graphics package basic charts, and there are some other also, but we will end up the graphics package here. But we will start ggplot2, because ggplot2 nothing but a grammar of graphics. Why we need to go for the grammar of graphics here means there are some drawbacks in the grammar of graphics, because see that what are the drawbacks? There is no print quality in the graphs that it was generated. Here you can see these are the graphs that we have seen, right? There is no print quality, and if you wanted to submit these graphs in an international journal, they are not up to the mark, so maybe they will get rejected. And you can see that the presentation is also not that much good. So to overcome all these, there is another package to overcome the drawbacks in the graphics package. The package is what? ggplot2. So GG stands for grammar of graphics. So grammar of graphics means while you are talking, if there is any grammatical mistakes, someone is there to correct, right? So likewise, if there is any mistake in the graphics package, so the someone here is ggplot2. So this is here is the someone who rectifies, who makes corrections of graphics package. So the advantage here, you can see we can get quality and presentation is very good in the ggplot2 compared to graphics package, so that you can use those images in any international journal. So see that what are the elements of grammar of graphics? So elements of grammar of graphics, see the first element there, that is data. Data is the first element in the grammar of graphics, and second element is aesthetics. So and the first element, one more time I'm telling you, the first element is data. Data is nothing but a data set or a data frame. So you need to have a data set or data frame. And aesthetics, so once you loaded the data into data frame, sorry, into the data frame, and data frame is available in the our environment, then you need to make some beautiful decorations for that. So for beautiful decorations means, if you want to apply the color, you can apply the color. And if you want to see the composition and with two different colors, and the parameters for aesthetics, x, y, fill, size, color, these are the parameters of aesthetics. And another one is geometry. So far in the graphics package, we have seen different kinds of charts, right? So different kinds of charts, and there are different kinds of functions. We have seen different kinds of functions, but they are different with geometry. Here also we can see geometry is a plot name. Geometry is a plot name, but the function names of graphics package is different with geometry. Here, if you want to see a line graph in the ggplot2, the geometry of line graph, or the function of a line graph, is GOM underscore plot point, POINT point, that is used to generate a line graph in the grammar of graphics. We will see each one. And the last parameter is facet. If you want to divide a large data set into subgroups in the visualization, so not in the actual data set, in the visualization, you can use the facet. Using facet, we can divide the data, right? So then we will see one predefined data set that is available in the our environment, that is iris. What is iris? Iris is a flower, right? So this is the iris flower. In the iris dataset, you can find sepal length and sepal width. This is the sepal. Sepal is nothing but a leaf. Sepal is nothing but a leaf. And petal. Petal is nothing but a line, a straight line, a middle line on the leaf. Petal. That is the petal. We will work with that. For that, I am opening again. I am going to my R environment, and I am clearing this Ctrl L. So I wanted to show you the data set of iris. So to see the data set of iris, you can use view iris, enter. This is the data set of iris. So sepal length, sepal width, petal length, petal width. You can see that sepal, S capital, L capital, right? And species are nothing but different kinds of flowers. There are three different kinds of flowers here: setosa, virginica, versicolor. These are the three different species in this flower. So we will see some of the interesting things using this iris data set. The first thing is if you want to plot a graph in using ggplot2, you can use this function ggplot. What is that? ggplot is a function, right? I am taking iris data set, and to apply the aesthetics, this is the function aes, aesthetics. So in the aesthetics, what are the parameters? Aesthetics is having x parameter, y parameter, color parameter, shape parameter, size parameter. These are the parameters in aesthetics. You can use any parameter based on your requirement. So here I require x. On the x-axis, I want to plot petal length. Petal length. So capital letters, right? And on the y-axis, I want to plot sepal length. So you can see that. And here, I wanted to see this using a line graph. So for line graph, the geometry is GEOM, geom underscore point. So enter. Error in ggplot, iris AES. Could not find function ggplot2. So sorry for that. First, before using ggplot2, you need to install what? You need to install ggplot2 live package, right? So I have already installed my ggplot2, but one thing I need to do is I need to load that installed package into working environment. So to load library, so library was loaded. Again this command, done, it's done. You can see this is the plot. This is the plot. You can see this is nothing but a bin. This is a rectangular box, is a bin. I have told you, right, in the box plots. This is nothing but a, when you increase the size of the bin, definitely there is a variation in the graph, right? If you increase or decrease, definitely there is a variation in the graph. See that these are the dots available, and petal length and sepal length. These are not giving any information, because the all lines are in black color only. I am not able to understand which piece of points are there. So I wanted to apply one more parameter here, here. I want to separate all these using a color attribute, and in the color attribute, here you can observe I am not adding any color for that. I am taking a value, a categorical value. I am applying a categorical value for the column. Categorical value is nothing but what? In the categorical value, I have three categories. One is setosa, virginica, versicolor, right? These are the species of iris. So here in the color I'm using species. So now These and x and y values are divided using this color species. So we will see different species here. SPECI, SPECIES. See that. Zoom it, zoom it. What? Yes, you can see that. Setosa is available in this color. This is the Setosa, and versatile. This is the versatile, and virginica. This is virginica, right? So after seeing this image, I can give one statement. What is that statement? Means you can see that when the petal length of virginica keep on increasing, then definitely what? The sepal length also increasing, right? Sepal length also increasing, and petal length also increasing. Nothing but what? The leaf of virginica is bigger while compared to setosa, because this leaf is very small, right? Small leaf. uh, because petal length is very small, sepal length is very small, so both smalls comes to give only smaller leaf, right? And virginica petal length is high, sepal length is high, so definitely the leaf size is longer while compared to setosa, right? Interesting observation. After seeing this graph, that is not possible by seeing the data set, right? And one more thing we need to do is we can play with the aesthetics. Aesthetics contains no, these are the aesthetics. See that? Yes, x applied, y applied, color applied. Instead of color, I am using shape, right? See that? Enter, and you can see here for setosa, it has given a shape circle. For versicolor, it has a given triangle. For virginica, it have given square, right? So if it is not that much good, you can apply color also along with this. No issues for that. Color also you can apply. Color is equal to, you need to take the categorical variable species, enter. You can see that along with the what, along with the shape, there is a color also. Good, right? And this is working with inbuilt data sets. That means already available predefined data sets that are available in the R environment. So now we will work with the data sets that are not already available in the R environment. First, what we need to do is we need to load that data from outside to our environment. So I have a data here. I have a data. See that my data is sets are available in F drive. F drive. Here you can see houses data set. This is the houses dataset, and not only that, um, this houses dataset is a CSV file. This is the CSV file, and here if you wanted to see very clearly, I will open this in Excel also. See that this is my CSV file. Here I have serial numbers and price of the house, lot size of the houses, waterfront. If the house is having waterfront or not, 0 indicates no, 1 indicates yes. Waterfront is no, 1 is yes. Age, house of the age, and land value of the house. Here, construction, is the house having air conditioner or not, fuel system is there or not, heating system is there or not, shower system is there or not, what is the living area of, how many number of fireplaces are there, bathrooms, how many number of bathrooms are available, how many rooms are available. See here, fireplaces. If the fireplace is available, then it indicates 1. If there is no fireplace, it indicates 0. Right, this is my data set, and it is available where in F drive, some folder. So I'm taking that path of that data set. What is that data set? Houses, right? I'm taking houses data set, copied, and I wanted to read the data. I wanted to read the data using read.csv. I am taking a variable called house, and read.csv, in the double quotation you can supply that path, and you can see these are the escape characters, right? So to nullify that escape characters, you can again give one more escape character, backslash character. Now if you press enter, all the data available in the houses.csv file automatically go into the house object. That is nothing but a object variable. So now house object contains data. So we will work with that data. We will see some interesting factors using available in that data. I can remove a column, first column. I know there is no need of serial number, right? Here you can see x.1 serial number. Already one serial number is available, but it is giving another one more serial number. So I wanted to remove that. To remove that thing from your dataset, you need a package called deployer, dplyr. So in my R environment, I have already installed. So installed packages must be loaded into the R environment. So Control L. I'm using library function to load that package. What is the package? dplyr, deployer. Done. So package was loaded. So you no need to forget about the red color messages. Okay, the package was loaded. Now what I need to do is, I'm using pipe symbols from the houses object. Houses object contains data. So I'm using pipe symbol. So see this, using this pipe symbol, I'm selecting the data using combine function, and in that I want to select first column, right? If you supply minus symbol in front of the column number, column index, that means except that first column, every data will be again stored into house object again. So I'm using another assignment operator. Done. So the first column was removed. You can see that x.1 is available in the previous, right? Now only x is available. So we will do some operations, and we will first we will start with the histogram. Using histogram, we will see some interesting information, interesting insights from the data of houses object, right? So see here, I'm going with the histogram, as I said, using ggplot function, ggplot of what is the data that I have? Data is equal to where my data is available, house object, right? Take house object, and aesthetic, AES, playing with the histories. And on the x-axis I want to take price of the house. Okay, price of the house. And here what is the plot that we are going to plot? The geometry here, geometry of histogram, GEOM underscore histogram, HIST, right? This is the histogram, and press enter. So that is a warning message. It is saying that use bins is equal to 30. If you have increased the bin size, you can get the better visualization. See that this is our histogram, this is our histogram, and here the price is plotted. Price is plotted on what? X-axis. But there is no interesting insight here. Just we have plotted x data onto the x-axis, price data onto the x-axis. So here what I want to do is I will plot prices data on the x-axis, and we will again apply color for that. We will again apply color for that, or you can use some, how many air conditionings are there, how many houses are using air conditionings. So for that I'm using the same command with a little bit of changes. See that x is equal to price. On the x-axis I am taking price, but in the aesthetics one more parameter is there, that is fill. Fill is equal to, I am taking air conditioning data. So air conditioning column name is air underscore COND, and that is available in numbers, right? So to convert them numerical data into categorical, I am using a function called factor. So air underscore COND, right? Now we will see how the plot looks like. So press enter. See the plot here. This is the plot, and 0 indicates air conditioning, houses have no air conditioning, and 1 indicates houses are having centralized air conditioning. See this plot histogram, and there are lot many houses that are not having air conditioning. Using this graphical representation, we can easily say that around houses ranging from $1 lakh to, here you can see $8 lakh, $8 lakh. The range of ACs are starting from here. There is very little bit of people, amount of people who bought their houses using $1 lakh are having minimum number of ACs. So there is no centralized AC. So maximum number of ratio is having people, they are not using centralized air conditioning. Interesting observation, right? So if you wanted to see composition, that means the composition means ratio of price and air conditioning. You can use another parameter, using the same query. Here in the histogram you can use position is equal to fill. So mention that in double quotes, position is equal to fill. Press enter. See this, you can look at this. This is the composition, nothing but a percentage. So much of the percentages you can see, those who are invested much amount, bigger amount, $8 lakhs for their houses, they are definitely having centralized air conditioning. These 2 points see, and some a lesser number of people who are having here. You can see that this is the ratio here. More number of people are having not having ACs. This is the composition. This is the you can observe a rectangular here. A rectangular. Two variables are combined together. This area indicates uh, houses having no ACs. This ratio, this color indicates houses are having air conditioning. And this is about histogram. We will go with the bar plots. So right, for bar plots we will take again same data, houses data. So I'm using dg plot, same function here, and same data. What is the data? House. House is the data set, and again aesthetics, AES aesthetics, and x-axis here we will change x-axis value. Here I'm taking waterfront. So I wanted to know how many houses are having waterfronts, but in this command I am just plotting waterfront along x-axis. Just I am plotting waterfront on the x-axis. Here the geometry for the bar plots is geom underscore bar. Here you can see this is the bar plot. This is one bar, this is another bar. According to this bar plot, I can say that you can see 0 and 1, right? 0 is 0 indicates no, 1 indicates yes. That means many number of houses within the range from 0.5 to 0.5 are not having waterfront to their houses, and very less amount of houses are having waterfront. Say nice, right? So we will see one more observation also. Sorry. The houses who is having waterfront, and I wanted to know, will they have AC's conditioning for their houses? Waterfront plus air conditioning houses. I want to see in bar plot. So for that I wanted to fill this same query, x is equal to waterfront, but here I am taking aesthetic, fill aesthetic. Fill is equal to factor of air underscore conditioning, right? It gives what? So see here, this diagram is telling that houses without waterfront. This diagram is telling that houses with waterfront. So houses without waterfront are having this ratio of air conditioning, and you can look at that houses. Here you can see that houses with waterfront definitely are having air conditioning. That means it is a little bit of line is following, right? A little bit of a line is following, right? Yes. So this bar indicates what? Without waterfront, with waterfront. Without waterfront, this ratio of people are using air conditioning. With waterfront, this ratio of people are using air conditioning. Good. And we will go to the polygon, and you can see the ratio also. How to see the ratio? Sorry, how to see the frequency ratio in this graph? You can set position is equal to fill, right? You can position is equal to fill. See that? This is the composition. This is the composition, and this bar indicates without waterfront houses. This bar indicates waterfront houses, and in this indicates what? Percentage of ACs that are using here, percentage of ACs that are using. And we will go with the polygon. Polygon is nothing but a straight line. Polygon is nothing but a straight line. So we will go with the same data set, houses data set only, and for that I'm taking gg plot function again. Here I am taking data is equal to house comma aesthetics AES. On the x-axis I am taking price, and what is the geometry? I wanted to take the frequency polygon, right? For the geometry for frequency polygon is geom underscore frequency polygon. Frequency poly. You can see that this is the graph that was generated. This is the graph that was generated, and if you increase the bin size, you can see a lot more difference. You can see a lot more difference. Here bins is equal to 100. I'm increasing bin size. See here, this is the previous diagram. This is the new one after increasing the bin size. Both are different, right? That is what I said. When you increase the bin size, automatically there is a effect in the graph that appears, that visualizes. It is showing a very clear picture of a graph. Then I will see using frequency polygon that on the x-axis I will plot price, and on the using color attribute is equal to air conditioning, that I will see how many houses are having ACs and how many houses are not having ACs using this polygon. Frequency polygon, I'm removing this, and here just you need to increase one aesthetic here, change one aesthetic, comma, what is the aesthetic? Color. So I am changing color is equal to factor of air conditioning, right? And see that you can see here, this is the houses that are having the price range. You can see the price range here. You can see the price range of houses that are not having air conditionings. Okay, along with price range, it indicates the high level indicate y value indicates what? More number of houses. These are the lesser number of houses that are having air conditionings. Okay, now we will work with the themes. Themes available in the ggplot2. They are very interesting and useful also. You can observe any if you are if you are a person working with the uh, Photoshop. In Photoshop you can see everything is a layer, right? Everything is a layer. So using that layers, you can apply as many colors as possible, as many changes as you can do. So likewise here also you can do a layered approach using themes, and every layer is stored in a particular object. So we will work with that, and for that I am taking again houses object. Houses object contains what? Houses data available with specified field names. I'm taking ggplot. ggplot. Here you can see it, ggplot. Data is equal to what? Data is equal to house, right? And I'm taking aesthetics. So aesthetics, I'm taking x. On the x-axis, I want to take number of houses. X is equal to factor of rooms, right? On the y-axis, I'm taking price of each house, and I wanted to fill this. I wanted to fill this with a color attribute or fill attribute. I will take fill attribute. Fill is equal to uh, factor of rooms, and for this I wanted to use a geometry of box plot. So for the box plot, the geometry is geom underscore do box plot. This is the geometry, and you can press enter here. This is the box plot. You can see that on the x-axis I have taken rooms, right? This is the box plot that indicates a house having 2 rooms, 3 rooms, 4 rooms, and here you can see house is having 12 rooms. And on the y-axis, what I have taken is price. When the number of rooms are keep on increasing, automatically the price is also keep on increasing. And one more interesting thing in the box plot is we can find the outliers, right? These are the outliers. So outliers are values that are beyond the range. So some more interesting things we will see using this, but before that I need to save this entire layer, this entire image in a object1. So this entire statement in object1, obj is equal to enter. So that entire image is saved in obj. So next, what I want to do is I will add another layer on the object. So and object obj2 is equal to obj plus is assignment operator, adding operator. For that object I wanted to give labelings, names for decoration purpose. So I'm taking title is equal to price with respect to number of rooms. That is all about that obj, right? Number of rooms. And on the x I am taking rooms. X is equal to number of rooms, and I wanted to fill the color for rooms only. Okay, enter. So object 2 is ready. If you want, you can print that object 2, otherwise you can use themes function. Using themes function you can set the background of the you will see this. I will print obj 2. Yes, this is the obj2. I have added layer here. What is the layer means? Price with respect to number of rooms. So I wanted to set this into center and make it colorful. And here you can see rooms and price. And here you can see one more thing. this background is not that much good, right? If you want to change the background, so we will see that how to change the background also. So in object 2 I have entire my image, and so I'm taking one more object 3 is equal to, so I'm adding one more layer to object 2 plus I'm taking theme now, theme panel dot background. So for the panel background, so panel background is in the shape of rectangular, right? So for rectangular, element underscore rect function you need to use, and that too in the element underscore rect use fill. You can take pale green, okay, this thing is enough. So entire thing will be saved into object 3. So object 3 is ready. I will print this object 3. See that the background was changed, right? The background, panel background was changed, and it looks good, right? And if you want to change this price, this is the previous picture, this is the new picture, and if you wanted to change title also, title has to be in the center and title has to be in some color. So for that obj3 no obj4, one more new variable is equal to obj3 plus, again you can use theme function, obj3 plus theme of plot dot title, plot entire plot title, entire plotting title, plot dot title is equal to actually you have given a title already here, there is a title for, but for that title you need to give some decoration. So plot dot title, so element underscore text, so I need to work with the text, right? Text h just is a parameter. When you adjust the h just 0.5, that indicates center, 0.5 is the center, and that text has to be treated as face must be bold, right? And if you want to apply a color is equal to, you can take anything. I am taking caded blue, right? So enter. So now I am printing obj, what that, obj 4. So this, see that in the previous picture you have your title here, and in the black and white color here you can see that it has some center, it comes to center, and that was having a nice color also. So this is all about working with the uh, outside data sets and making your plot very good. And this is the difference. You can see using ggplot you have designed very good plots, right? Compared to graphics package. So this is the end of the session. If you people are having any doubts regarding this lecture session, you can comment below. I will reply as early as possible. Thank you.